for the log transformation of the amount, we just want to. So basically, why the reason why we don't want outliers is because the model might put much greater emphasis, for example, on if it's 1000 and it's, let's say, 300, so it might put much more emphasis on the 1000, thinking that the 1000 is a much better predictor. That's why we need to reduce the difference, especially between variables that have very large outliers, so that when you are predicting, the model does not look at the difference between those two as very significant. We want to reduce it and make it a little bit more standardized. I don't know if that was clear enough. So did any of you have a chance to look at the IPython notebook that we used last time, or try anything on your own? I don't know if any of you had the chance to look at it, or you tried to load it and just try and run. So I think we go on and start with the logistic regression model. So mainly the logistic regression model is just a classification algorithm that we use to predict binary outcomes. For example, if I'm trying to predict a true and a false, okay, I see some people actually tried and run the IPython notebook. That's actually very good. So I think we'll go through this, and then I will ask him for a practical session. We'll go to the labs and maybe try and do it practically. You see, basically, I love to use Excel when you're doing most of this, especially when you're beginning something. It's usually good to start, for example, with Excel, since you see how the data is moving. So for those of you who didn't have the chance, I really encourage you to try and just run the notebook. You might not understand at first, but the more you look at it, the better you become. So as I was saying, the logistic regression model is just a classification algorithm used to predict whether it's a yes or a no, or a true or a false. So in our case, to predict whether somebody is going to be given a loan or not, based on our independent variables. So the logistic function, it will create something like an S-shaped curve. How many of you know how to calculate odds? You have seen it so many times. I'm sure most of you actually know how to calculate odds. Let me write for you the question. How many of you know how to calculate? I'm sure you have seen it so many times. For example, when most betting companies actually use them. So basically, how you calculate odds is just okay, Patrick, I see you're saying you don't know. Anyone else who wants to try? Yeah, okay, Alan, I'm seeing you actually know how to calculate the odds. I don't know if anybody else wants to try. Yeah, so basically how you calculate odds is just the probability of something happening divided by 1 minus the probability of that thing happening. So it's P over 1 minus P. So for example, if you're doing a heads and a tails, it's probability of a heads divided by 1 minus the probability of a heads. So basically it will be 0.5 divided by 0.5. So the odds are 1. Odds of heads and tails will be 1 to 1. So that's basically how you calculate it. So that's that's usually used as the building blocks for the logistic regression. We usually just calculate the odds of something happening. For example, in our case, it will be the odds of us getting a loan or our loan getting accepted. So as you can see, we'll drop the loan ID. So if you're following from the previous dataset, we'll be dropping the loan ID, as this is just a unique identifier just to see each loan, so it doesn't affect the loan status in any way, since it's just a unique identifier. Mainly it's just used for a database. So we'll run that. We'll drop it for both the test and train. So it seems I had already dropped it, so that's why it's bringing the value error. So as the library we are going to use is the skitlearn. It's one of the main libraries we use in Python for importing the most models. So we'll be using skitlearn. So we'll be dropping the loan status, and so we'll just drop it because we want it to be in a separate dataset. That's why we are actually dropping it from the train dataset. So after we drop the loan status, we'll be creating dummy variables. You know how many of you know how dummy variables works, or have ever seen how a dummy variable works? For example, for gender, if you can give me an example. Don't know. So for dummy variables, yeah. So actually, Alan, yeah, they're dichotomous. It can be a 0 or a 1. For example, if you are doing a dummy variable for gender, we have two genders, male and female. So if you're doing a dummy variable, we'll do maybe male will assign it 1, female will assign it 0, or the other way around, male will assign it 0 and female will assign it 1. So the reason we need to do that is because most of these models don't actually take text data. So you have to assign it a dummy variable so that you can run the model using it. So it can also run up to, there are some, most dummy variables are calculated for categorical variables. For example, the urban, those who live in urban, semi-urban areas, we just do a dummy variable, let's say 0 or 1 there, so that the model can run. So we just run this, how you get variables. So once we have assigned the dummy variables, we now train the model on the training dataset and try and make some predictions on the test dataset. That's actually the main reason we split the model into the dataset into the train and the test, so that we can validate our predictions, see whether they are actually correct or they're not correct. So we will import the train test split. So the train test suite, mainly we just use it to split our data set for the training and the testing. This one is, you just do it for the X train, the X tests, and the Y train and the Y tests. So mainly this, you just, after doing it for some time, it's not that difficult. You just understand how this code runs, especially those of you who are into Python. So don't worry about how these data sets are arranged. So one thing you just notice is how you name your data sets for the training and for the training you just use the X, and for the testing you just use Y. And then you'll also notice I put some capital letters on others just to separate these two. So okay, so the random state, basically what I do here is just to ensure so that when you run the model you just get the same results as me. So I also specify the test size. I want 30% to remain as test. So we just run that. So here we'll be importing the logistic regression function and also the metrics which we'll use for the accuracy measures. So I could have used just this last line could have been okay, but those of you who are familiar with Python, you know you can use the dot operator to access most of the functions. So if any of you have any questions as we go on, please ask. Because the model building, this is usually a little bit complicated if you've never done it before, but it's actually easier once you try once or 2 or 3 times. It won't be that difficult. So we store the regression model. We'll just call it the logreg. So this is the dot operator I was telling you about. So this is where we instantiate the class for logistic regression and store it under logreg. And then here we just access the method called fit. So we'll train, and the Y train. We train the data set using the data set, how do we call them? The independent variables are in the X train, while the dependent variable are in the Y train. That's why I actually named them this way. So the X test and the Y test here, these are the independent variables and these are the dependent variables. So you fit logistic regression here, and then we will predict them. We try and predict them using the data set, the independent variable in the X test, as we have done here, as we had already separated it here, and then we try and compare it with the Y test here. So that's why we actually use the train test split. I don't know if any of you have any questions up to there, so feel free to ask any question. So once we run this, should be able to run. Okay, we'll run that. So we reached the model level. So here we have already run the model. That's why I was telling you I prefer the Excel, since when you run in Python, you see what's going on. For example, we have already run the model here, so you can't really see what's what actually happened with the data until we start doing the model evaluation. So that's how easy it takes you to run a model in Python. It doesn't take a lot of work. So here the C parameter, this one of the things in the logreg class. So it's just to reduce the, for example, the overfitting. For example, if your data fits too much on the trained set, so we use it to reduce the overfitting, so that in case you are using a test data set, your model is not so much off. So that's why we use the theta, though you'll not be able to see it when you run here. You just have to run all these runs one by one. So the independent and dependent variables. So basically, when you are doing, for example, if we are trying to predict something and you are looking at the thing that we are trying to predict, that's the dependent variable. But the things that we are going to use when you are predicting the dependent variables, that's when we call it the independent variable. For example, you call in machine learning, you call it features. So features are the independent variables, the variables that you use to predict the dependent variables. So I don't know, Sanjam, if that's okay with you. So that's why in statistics we usually call it the dependent versus the independent variables. So feel free if okay. So that's good if you have understood. So what a confusion matrix does, so here we have reached the model evaluation using a confusion matrix. So what a confusion matrix does, it's basically a matrix where we can see the actual. So we'll just put a matrix and see the actuals that we have versus those that were predicted. For example, we'll look at the diagonals. The 22 and 132, those are that's the diagonal we want. So we want most of our values to be either in the 22 or 132. So the other ones we'll just be doing a matrix where on the right side will actually be the actual versus on the upper side will actually be the predicted. So in between those four cells, the files on your right, on your top right, that will be the true positive. On the other side, that will be the false negative. On the bottom right, that will be the false positive, and then on the bottom left will be the false positive, and then on the bottom right will be the true negative. So what means is for the true positive, those that are actually true and they were predicted true. So on the true negative, those that were actually false and they were predicted false. And then on the false positive, those that were actually false but were predicted true. So, and then on the false negative, those that were actually true but were predicted false. So I don't know if anyone has a question on the true positive, false negative, false positive, and the true negative. So if anyone doesn't have a question there, so that's what we call the confusion matrix. Basically, we are just trying to see how many were misclassified, or we can also call it the misclassification matrix. So the confusion matrix is usually very good when predicting in classification models, since you already know where the dependent variable is expected to fall. So in order to calculate, for example, the accuracy, we can just take the true positive plus the true negative divided by the total, which will be 22 plus 29 plus 2 plus 132. So the true positive and the true negative will be 22 plus 132 divided by the total. So we will use that to calculate the accuracy. So let me just do that. So once again, don't worry about the libraries or how these are done. Most of this stuff, you just Google it and you just get it. So here again, so this is the confusion matrix. So I was saying on the left side will be the actual label, and then on the top side will be the predicted label. So the predicted labels will be 22 and 2 on the left side, and then 29 and 132 on the right side, and the actual labels for 1 will be 2 and 132, and then will be the false will be 22 plus 29. So those are the true positive will be 22, the false negative will be 29, the false positive will be 2, and then the true negative will be 132. So I don't know if that makes sense. If any of you has a question, please feel free to ask. So this is how you do a confusion matrix. So once again, don't worry about the code. You should usually, either as time goes by, you just know how to write code like this. It's not that difficult. So so for classification problems, we'll be having three things. We'll be having the accuracy, precision, and recall. So those are the three main things that we'll be looking at for the matrix. So those you can just write, you can just get them here. So the accuracy will be 0.83, the precision will be 81, and the recall will be 98. So for example, the recall will be seeing how good you can predict the false. For example, that will be the 132. That's why you're seeing the recall is such a high number. While the accuracy will be 83. That's how well you can predict all the values in their correct boxes. For example, how well you will predict the true positive and the true negative. So that's the accuracy. And then the precision will be how well you can predict, for example, the zeros. That, for example, the false values. So that will be the for precision. So the main thing about a confusion matrix is just we are just looking at how well we are going to predict the values in the boxes. So that's why it's actually called a confusion matrix, or you can actually call it a misclassification matrix. So feel free to ask any question. Feel free to ask questions. Yeah, so as I was saying, I will ask team mainly for a lesson where we can actually go and do most of these things in Excel. Yeah. because the problem is when you do most of these things in, for example, in Python, as you can see, you can't really see where most of the data is going. You're just seeing how the model is running and how, and just importing the libraries. They're already pre-made for you, so it's usually very difficult to understand how these things are, how these things come about. So yeah, so Keter, I actually understand how hard it is for when you're doing that. So I don't know if anyone else has a question before we proceed. So I will ask him if he can do actually a practical lesson where I prefer to do most of these things in Excel. So that especially when you're doing it for the first time. So especially when you're doing it for the first time, so that you can be able to actually look for yourself how, for example, a logistic regression is done, and how everything else comes about. So from our model, you can see the accuracy is actually 83%. And the precision is actually the measure of the correctness achieved in the true detection. That the labels, the observations labeled true, so that will be 22 and 132. So usually a very thin line between the precision and the accuracy, while recall is the actual measure of the observations that were predicted correctly. So how many observations in the true class were labeled correctly. So put the explanation there. So feel free, they're usually very confusing at first. So feel free to ask questions. So we have reached the ROC curve. So as you can see, the model building phase is usually not very long, but a little bit more complicated. But don't worry, this upper part is usually the most important phase that we went through last week, since this is the phase that actually determines the variables that will go into the model. For example, if you have a model that runs using almost like 50 variables, there are some rows that you would actually need. So the top part that we covered last week will actually determine which variables will go into the model. So as you can see, the precision, we are done with the precision and recall. So we'll go to the ROC curve. So the ROC curve basically is the receiver operating curve. So I think most of you have actually heard of the ROC curve. I don't know how many of you have heard of that. So the ROC curve is a plot of the true positive rate against the false positive rate, and it shows the trade between the sensitivity and the specificity. So that will be when you draw a line. For example, when you draw a line here, you can just follow my mouse. So when you draw a line here, if the ROC curve would have been around the line that was connecting this side and this side, that means it is almost 50-50. So there's no difference between guessing and our model. So when our model, for example, in this case, is just above the we call it the guessing line. So for example, here you can see the ROC curve actually moves towards 1 and then flattens off at the top. So it has an AUC of 77. So an AUC of 1 actually is a perfect classifier, and 0.5, which I was just calling right now the guessing line, it represents a worthless classifier. So that's why you can see our model has an AUC of 77, so which is actually very good. So that's actually the basics of how you run a logistic regression model. I don't know if any of you have any questions. So this lesson was actually short because of the it was just the modeling part that I had left the previous time. So I don't know if any of you have any questions. So I will have a talk with team and see if you can actually do most of this stuff in Excel. So because I would actually prefer most of you to actually see how we are calculating most of these things. Because the problem with Python, as you can see here, most of you don't actually know even how the formula of calculating the accuracy versus the formula of calculating the precision and the recall. So we'll actually do those in Excel actually practically, so that you can actually see. So basically what we are trying to do is just trying to, for the classification matrix, we are just trying to compare the ones that we have predicted. As you can see here, the Y test, this is the actual value versus the Y predicted. This actually the values that we predicted. I think you saw it here. This is the value that we predicted here. So basically what we're trying to do is just compare the two and see how well our model for predicting worked. So that's why we use these three measures for most classification models. So and then you finish off with an ROC curve to see how your model performs against, for example, a worthless classifier which has an AUC of 50, which we usually call the guessing line. So in a nutshell, that's how you do logistic regression, and being able to predict the ones that will actually default, or those that are going to be accepted versus those that are going to be rejected. So in another case, this would have predicted those that were actually going to default or those that were actually going to pay. So as I had said earlier, I will talk to team and see how we are going to do a model using Excel, because I would really love most of you to actually see how we are doing most of this stuff. I use Excel as mainly because most of you will actually see how we calculate, for example, these tests like the accuracy, and actually how to do a logistic model in Excel, not just write a function and just fit it like that. In Excel, it won't be that simple. You actually have to see how you are going to do your dummy variables, and actually how you're going to do the odds and the log odds. And then I think we will finish off with building a scorecard. So that's where we'll just be inputting the data and getting the results of whether somebody will have been accepted or rejected. So I don't know if any of you, yeah, Mr. Agwan, yes, I'd actually suggested to Tim this is the main reason why we need to do most of this stuff in Excel. Because in Excel you actually see how you're going to go about most of these things. Because it's more practical than just running a IPython notebook. An IPython notebook, you won't really understand how most of these things come about. And actually explaining to anybody else will be a little bit difficult. So I think we can arrange for one of these Saturdays. We meet on the lab and actually do this in Excel. So you see how you create dummy variables and also the data exploration phase. You see how to actually also even the log transformations, you actually do them in Excel, though it's going to be a lot of work, but I think most of you actually need it since some of you are actually beginners. So instead of just running most of these things in Python. So I don't know if anyone has a question there. Feel free to ask any question. Because I think we have come to the end here. So the next phase, I'll be asking team if we can do this now on Excel. I think that would be the best. So how many of you would actually love to do it in Excel rather than in Python? So let me write you a question. Yeah, I understand. Most of you actually love to do this in Excel because even me, as I was starting Excel, I think would be the best way to. Yeah. So Susan will be doing it in Excel now. Once you have now the notebook, so that will actually be very easy. It won't even take you a lot of time because as I had told you earlier, most of the model building part doesn't take a lot of time. That's not most of your work won't go to the model building part. It's just a model. Once you run, it's good. But for the data exploration phase, that's where you have run a lot of hypotheses. You have to investigate a lot of things. You have to redo most of the things that you have investigated. And also, I think I didn't also add one of the variables that we had found was going to be good, which was the total. We had done another one for the total income. I think it was the total income of the applicant and the co-applicant. Yeah, the income of the applicant and the co-applicant. So we have not also included that in yeah, this was the one I was talking about. The total income of the applicant and the co-applicant. So we haven't even added it in the model. So most of you, I don't know how many of you would love to try and see if you add that and remove. So once you add the applicant and the total total of the applicant and the co-applicant. You'll notice when you run the correlation matrix, it will actually have a very high correlation between the applicant's income and the co-applicant's income. I remember last lesson somebody had asked me why you actually need the correlation with the total income. You won't actually need the applicant's income and the co-applicant's income, since they are both factored into the total income. So that's why you actually need the upper part, this part of that exploration. So I don't know if you have any questions. So as you can see, we can end here and I'll see how I'll organize another lesson so that we can do most of this in Excel. I think most of you are going to benefit a lot from Excel compared to when you're doing it in Python, especially when you have just started, because there are also some other models that you can actually do in Python. But I would love us to start with the logistic regression first.